Okay, this is the problem that a lot of students, including me, struggle a lot during the differential equation recitations. And the key idea here is very simple. Basically, we need to find the implicit functions. Implicit function of these differential equations. And since we know our goal, and we need to use our tool to go there. And we know the quotation for an exact differential equation is that the partial m respect to partial y and the partial n respect to partial x. That means for function m, we're gonna do derivative and treat y as a variable. So we can short write my like this, and for n also do the same thing, which is we treat x as a variable. We do this. Then, in order to find the exact differential equation quotation, we have to prove that my equal nx. And this m and n is really coming from the implicit function. Let's see, I call f(x,y) equals 0. Then for m, it's coming from f(x), and n comes from fy. Then the ultimate quotation is f xy equal y fyx. Okay, since we already have a quick review about the tool that we need, then we're gonna do is solve the problem. How we can find the implicit equation above. Okay, so we have m is equal this. Then what if I do integration respect to x to restore the implicit function? Okay, then I can do like this. Let's say fxy is equal this m dx plus dxy. Okay, then we're gonna put the here into the equation, which is plus dx, which is this. Then we're gonna do integration by part. Integration by part. Okay, then I will say get this xy. This step is y dx, and we treat y as a constant, right? As some number. So there is no x here. Remember the basic integration techniques? Then we will get xy, right? But usually if we do integration, it need to have a constant. But how we could construct a constant here? So in the beginning, we know that we have an implicit function. Which is fxy, and we do the integration respect to x. So if we go back, are there possible that our constant may be content or constant, maybe content y? I think so, because if we put some random, let's say hy function in the beginning, of fx function, then if we do derivative fx y plus hy respect to x, then for a function purely compromised, purely use y as a variable, then here is a disparity, because there is no x in hy function, right? So I will put hy here. That's when we do the integration to restore the implicit function. Okay, So we have f(x,y), then in place in the function, and we have the function that we need, right? But the problem that we have another integration that we have to solve. So only left for the function is that we have this integration need to solve. Then how are we going to solve it? And we need a trig substitution. In order to do the trig substitutions, we have to find the purpose reference triangle. Remember, we have a 3 reference triangle. One is this. Another one is this. X equal to a sine theta. And another one is this. Ax equal a sec theta. And we have this. Okay, then which one do we think is appropriate? Then I'm gonna look the underneath, which is here, to find they all look similar. Maybe I can use that. Okay, then we have a an angle, and we have theta, and we have 1, which we replace the a here. We have x, and we have 1 plus x squared. Then how are we going to do next? I will say I want to transfer or replace all x into theta. Okay, then we know cosine theta is equal to 1 divided by this. And sec theta, which is 1 divided by cosine theta, is equal to this. We can replace. So 1 sec theta dx. But we still have dx left. How we are going to solve this? I would say tangent theta equal x divided by 1, and x equal tangent theta. Then dx is equal sec squared d theta. This is the differential equation. Yeah. Then I can fully properly replace, which is here. Replace sec square d theta, and we finally get this d theta. And this is not easy to solve. So we are going to refer the integration table. It gives I need to find that equation in my book. It gives this. Sec theta plus tangent theta plus c. So our problem from here we get solved to this. But we have to replace back x. From the triangle we use. So secant is equal to 1 cosine theta is equal to 1 plus x squared. Tangent theta is equal to x divided by 1 and x equal tangent theta. Then finally we get is 1 plus x squared plus x plus c. Okay, we need to go back to look at the whole picture. Remember in the beginning we have this, right? Then we can have confidence to write down the implicit equation that we are seeking. Y plus c. Then we still have another last problem is here. How could we find that? Hy. When we refer back to our problem, we know here we know n is Fy and we have F, right? We already have F. Then we can do, which is Fy equal x plus x, right? Because here no variable y all cancelled. Here has, right? Then we do the derivative with respect to y and we get x left over. And here, and then we do the derivative with respect to y, right? And c cancelled because no y. Then we can compare, right? Compare these two functions. Can compare. They must be equal because we only have one implicit function. Then we know that each derivative is equal to 1 divided by 1 plus y squared. Then we need to find hy, which is this, right? We do the integration. Ooh, it's a long journey. Then we have hy is equal to this. Does this look similar? Yes, it's very similar to this one, right? We do here, right? They just change variables. Then we can quickly get the answer from the first couple steps we do. Is equal to this plus, we just change the variables, y plus c. Then final of the final, which is we need to put this all together, and final of the final, this all together. Then fxy is equal to this plus xy plus this. The key point we need to remember here is, first, what is implicit function? Second, how to decide that there is an exact equation for differential equation, for differential equation, for the first order differential equation. And last, we need to remember this, right? Another way is m y equal nx. Then one of the integration techniques we use here is trig substitution. Use the reference triangle properly. Okay?